Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. We have been focusing on ISS and this academy is exclusively for ISS only. We have completed and now we have completed regression. In regression, we have started regression estimator and double sampling, in which we have completed biasness of the regression estimator. And today we will complete the MSc of mean of regression estimator in double sampling. After that, our double sampling will be closed. And from the next lecture onwards, we'll start with a new topic, either cluster sampling or two-phase sampling. We'll see what are we going to do next. So today's topic is MSc of mean of regression estimator in double sampling. Let us begin. So this is the MSc of regression estimator in double sampling. Recalling what was regression estimator. Mean of regression estimator is represented by y bar cap small rd, where r is for regression and d is for double sampling. It is given by y bar plus beta x bar prime minus x bar, where beta is nothing but sxy upon sx square, and x bar prime is the estimated value of the auxiliary variable. Right? We did some of the derivations. We took epsilon 1, or we can take e1 x bar as 1 plus e1 capital X bar, x bar prime as 1 plus e2 capital X bar. Then we took sxy as 1 plus e3 sxy, and sx square as 1 plus e4 s capital Sx square. These are the four things that we considered, because this biasness and MSc cannot be derived directly. So we'll take approximation method, and in approximation method, we'll consider some of the digits as these. Now, what is meant by MSc? Mean squared error of regression estimator in double sampling is given by estimation of mean squared error minus y bar whole square. Now this can be written as estimation of what is mean square error, small y bar plus beta x bar prime minus x bar minus capital Y bar whole square. Taking them all together, we will be getting y bar minus capital Y bar as one unit, and beta x bar prime minus x bar as the other unit, and its whole square. So now we'll open this beta. We know that beta x bar prime minus x bar can be written as beta can be written as sxy upon sx square, and this can be written as x bar prime minus x bar. This sxy can be written as 1 plus e3 capital Sxy, and denominator can be written as 1 plus e4 small sx square, capital Sx square. And this can be written as 1 plus e2 minus 1 minus e1. Right? I have opened the bracket and we are left with this sxy and sx square can be written as beta cap, and this further can be written as 1 plus e3 into e1 minus e2 into 1 minus e4. So we are taking up to the power 4 up to the power 2. So we can also write plus e4 square, and after this all units will be ignored because they are more than power 2. Now if we open the bracket, we are left with beta cap e1 minus e2. Rest all the units are more than power 1, and we are taking square. If we'll square the power 1, then we'll get power 2. If we square the power 2, we'll get power 4, and we are taking approximation up to power 2, so we'll ignore all other terms and we are only left with beta cap even minus e2 in place of this. So replacing this here, we will get MSE of mean of regression estimator in double sampling is given by estimation of y bar minus capital Y bar plus beta cap into E2 minus E1 whole square. Now taking the whole square, estimation of y bar minus capital Y bar whole square plus beta cap whole square, estimation of e2 square plus e1 square minus 2e1 e2 plus 2 beta cap, estimation of y bar minus capital Y bar into e2 minus e1. This can be written. Now estimation of y bar minus capital Y bar is nothing but variance of y bar, and this here can be written as beta cap square, estimation of e2 square, we did it yesterday. Estimation of b2 square is nothing but 1 upon n minus 1 upon capital N into sx square upon x bar square. Also we are missing one term here. There will be a, not here, here. If we multiply it, we'll also get x bar. So here one more unit is there, x bar. X bar square, and here also there is x bar. So we'll write x bar square here as well plus e1 square 1 upon n bar minus n prime minus capital N into sx square upon x bar square, and minus 2 e1 e2 would be minus 2 1 upon n prime minus 1 upon capital N into sx square upon x bar square. This completes the bracket. Now opening the second bracket, we'll be getting 2x bar beta cap, estimation of y bar minus y bar into e2 and y bar minus y bar into e1. So first estimation would be e2, for e2 we'll get 1 upon n prime minus 1 upon capital N into sxy upon x bar, and for this e2 it would be 1 upon n minus 1 upon capital N into sxy upon x bar. These are the terms. So here it is minus 2n bar and plus 2n bar. So it will become minus n bar. Taking this on the other slide, MSC of mean of regression estimator in double sampling, we will get variance of y bar. Now here what are we left? Beta cap square into x bar square and 1 upon n bar minus 1 upon capital N. N minus n bar sx square upon s square. So it will be beta cap square x bar square 1 upon n prime minus 1 upon n minus 1 upon n prime minus 1 upon n prime into sx square upon x bar square. And this one we'll get n prime minus n. But here it is n minus n prime, so we'll take minus sign common and we are left with minus 2x bar beta cap 1 upon n minus 1 upon n prime into sxy upon x bar. Now here beta cap x bar square and x bar square and x bar and x bar get cancelled and we are left with variance of y bar plus beta cap square into 1 upon n minus 1 upon n prime sx square minus 2 beta cap 1 upon n minus 1 upon n prime into sxy. Taking 1 upon n and 1 upon n prime common, we will get variance of y bar as 1 upon n minus 1 upon n prime. We will take common and we are left with beta cap square into sx square minus 2 beta cap sxy. Here we can take common, we can open beta cap. What is the value of beta cap? We derived it before. It is capital XY upon Sx whole square. So taking the value of beta cap here, we'll get beta cap square is Sxy square upon Sx की power 4 into Sx square and minus 2 beta cap would be Sxy upon Sx square into Sxy. So this would be variance of y bar plus this 2 will get cancelled with this 4 and we are left with 2. So this would be 1 upon n minus 1 upon n prime. Now here sx square upon sxy square upon sx square minus 2 sxy square upon sx square will get us minus sxy square upon sx square. So taking that minus here, we'll remove plus and we are left with sxy square upon sx square. Now MSE of mean of regression estimator in double sampling gives us variance of y bar in minus 1 upon n minus 1 upon n prime into sxy square upon sx square. Now we know that sxy is nothing but rho sx into sy and whole square would be square of all the terms. So replacing that here, we will be getting variance of y bar minus 1 upon n minus 1 upon n prime into sx square rho square sy square, because sx and sx square gets cancelled. We are left with this. Now opening variance of y bar. Variance of y bar is nothing but 1 upon n minus 1 upon capital N sy square, and this would be minus 1 upon n minus 1 upon n prime rho square sy square. Taking the common denominator same, suppose we are taking cap n, so we are left with sy square as common, 1 minus rho square upon small n plus rho square sy square upon n bar. Here we are ignoring capital N terms. So we are left with this, and here from here only we can say that clearly mean of variance of regression estimator in double sampling is more efficient than simple random sampling, because this is MSE of regression estimator, which is more efficient than simple random sampling. And this is the formula for MSE of regression estimator in double sampling. So this completes your topic, regression estimator of double sampling. All the three estimators, ratio estimator, product estimator, and regression estimators we have done. Both their biases and their MSCs. Now we'll continue in the next lecture with a new topic on on sampling only, and soon sampling will be over, and we'll start with the new topic from the same paper. We'll complete paper 3 altogether, and after that we'll start with paper 4 or paper 1 or 2. We'll see that afterwards. I hope you're doing whatever lectures are we giving you. I hope you're watching them regularly on a regular basis, and working on your field where you are little lesser and you know it very well, where in which part you have to work more hard. So keep on working with consistency, and we'll see you in next lecture. Till then, keep on working hard along with English and GS as well. Thank you, all the best.